All right, we're going to continue our lesson about factoring trinomials, but the ones that we have factored in the past have always had a coefficient of 1. The leading coefficient here has been a 1, and we would always break down the last term to find a combination that would add to be the middle term. Well, today we're going to go ahead and have a coefficient other than 1 with our squared term or our leading term. So what we need to do is not only take the factors of the last term, as we've been doing, we need to also take into consideration all the factors of the first term. I'm going to show you how to combine those to find a pair that will end up working out to be your middle term. Okay, so that's what we're doing, taking the factors of the first and the last that combine to be the middle. So I'll show you with a few examples. Remember, you can pause this anytime. All right, let's move that up. So let's try this one here. 2x squared plus 7x minus 9. So the factors we're interested in are now not only the 9 at the end, but the 2. So we need to break down both of those values. And right now I'm not going to worry about the signs at the moment. We only have one option here, but we have two options here for factors of 9. You need to write all the ways you can to multiply two numbers to get those values. All right, so we know we're going to be multiplying two binomials. So when you're foiling out the process of multiplying two binomials, you know that you'll take the first times the first, and you need to get a 2x squared. So this is the only option we have to do that. So we know that the 2 and the 1 will go in the first spots, but we need to figure out if it will pair with the 1 and the 9 or if it will pair with the 3 and the 3. So I'm actually going to pick a combination that I know doesn't work so you can see what happens if you choose one that doesn't end up working out. Because if one doesn't work out, then you go on and try the next pair. What you're looking for are the outer and inner terms. To get the outer and inner terms, and we're talking about when we use FOIL to multiply out two binomials, the first, the outer, the inner, and then the two last ones. We want to figure out what will be the outer and inner. One value from the first number will multiply by one value from the last number. And they will create your outer and inner terms. So if I set them up like this, one way to get a value from this set to multiply by a value from this set is to multiply up and down. So you have 1 times 3, which is 3, and you have 2 times 3, which is 6. These will end up being a 3x and a 6x when you end up foiling it out. But you need to see if there's any way these can combine, any way they can be added to get a 7, and there's not. But another way to multiply a value from this set with a value from this set is to go diagonally. But notice because the 3 here is a repeat, we're going to end up with the same results. 2 times 3 gets us a 6, and 1 times 3 gets us a 3. And again, there's no way to combine those to be a 7 in the middle. This is our goal. We're trying to get a 7x. To do that, the factors from the 2 must multiply by whatever factors you pick from the 9, and that's got to combine to get the 7. So we're going to move on. That didn't work. We're going to try the 1 and the 9. Again, one way is to multiply up and down to get one number from up here to multiply by one number down here, but another way is to go diagonally. If I go up and down, I'll have 1 times 1, which is 1, and 9 times 2, which is 18. So those would end up being my outer and inner terms. There is no way that they would combine to be a 7. So that is not going to work. But another way to get 1 up here to multiply by 1 down here is to go diagonal. 2 times 1 gets you 2, and 1 times 9 gets you 9. I can get a positive 7 from this combination. If my 2 is a negative and my 9 is a positive, those will combine to be a positive 7. So I need to try to make that happen. So in your parentheses, these are the numbers that we're going to place. the numbers that ended up working out to get a combination to get us a 7. Do not put these numbers in the parentheses. You will not see this 7 anywhere. You'll only see the 7 after you do the multiplying. All right, so I'm going to go ahead and place the 2x here and the 1x. It doesn't matter what order these two numbers go in, as long as they're both in the first spots. Because when you do 2x times x, that will get you the 2x squared. Now, since I placed the 2 here, it's one of my outer values. My other outer value will go here. These two will end up multiplying together. So think about who you ended up multiplying the 2 by. This is what we were looking at. This is the 1 and the 2 that I already placed inside. The 2 has to get multiplied by the 1. The outers are linked together, and so linked together over here, the 2 and the 1. In order for the 2 and the 1 to get multiplied, that's where they need to be. Now, when I do multiply, I want to get a negative 2. So in order for this to multiply out to be a negative 2, I need a minus sign. Now the 1 here, I made an inner number, so the inners get linked when you multiply them together. So look at who you linked the 1 to. You want it to be multiplied by the 9, so the 9 has to be here. There's your 1x times 9. That'll get you a 9x. We want it to be a positive 9, so I need a plus here. And that should be your answer, your factored answer to that trinomial. You can always double check, multiply it out just to make sure it matches. So you can see also where the 7 comes from. 2x times 1x, that gets you your 2x squared. The 2x times negative 1, there is your negative 2 that you needed right over here. And then 9 times 1, there's your positive 9 that you needed over here. And then it ends with a minus 9. These two will combine to be your positive 7x. So this is the final factored result. Let's try another one. All right, on this one, we need to break down the 6 and the 10. Again, we'll worry about signs later. We know we'll have two binomials being multiplied if it's factorable. For the 6, we can have a 1 times 6, or we can have a 2 times 3 combination. For the 10, we've got two options as well, 1 times 10 and 2 times 5. All right, we are trying to get a negative 11 when we multiply one of the values from one of these sets with one of the values from over here. We want to try to get a negative 11. So I'm going to try the 2, 3 with the 2, 5. If it doesn't work, we'll try another set. There are 4 options here that you need to try. The more options you have for each number, the more attempts you might have. But eventually you'll get to the point where you can kind of take a look and eyeball it and notice what might go well together. All right, we'll put the 2, 5. If you line them up vertically, and then it's easy to kind of multiply one number from the top with one number from the bottom. Now, if I go diagonally, I multiply and get a 6 here and a 10 here. If those are my two middle terms, there's no way I can combine a 6 and a 10 to get a negative 11. So I know that option won't work. But remember, you can also try up and down. You always have 2 ways to try it out, diagonally and up and down, as long as you're lining them up like this. If I do 2 times 2, I get 4. 3 times 5, I get 15. So those two could possibly be my middle terms, and I think that will work. If I get a negative 11, remember the two middle terms have to be added to be a negative 11. If my 15 is negative and my 4 is positive, those will add to be a negative 11. So this is the combination that works, and those are the numbers that'll go in the parentheses. You will not put these numbers in the parentheses. You'll only see them when you actually FOIL it out. So we'll place the 6 first. That order doesn't matter as long as they're both in the first spots. You could put the 3x before you put the 2x. But because I chose to put the 2 here, I made the 2 an outer, So when you're foiling out, outers have to get multiplied together. So the 2 has to get multiplied by the number that's over here. So go ahead and look. Here's the 2 and the 3 that I have already placed inside. My 2 has got to be multiplied by another 2 in order to get a 4. So I can't put the 2 here because these 2 will never get multiplied together. It's got to go here. And I want it to be a positive 4 when I multiply, so that needs to be a plus. The 3 is an inner, so it's linked to your other inner. When you multiply, they'll get multiplied together. So over here, that's the 3 that's already inside. I know I need to multiply it by a 5 to get that. And it's a negative 15 that I want to get, so I need to make sure that's a minus 5. 3 times negative 5 is negative 15. If you were to FOIL that out, this is the trinomial that you would end up getting. So this would be your factored answer. Remember, factoring is writing it as a product. So we're going to try one more of these. All right, if you take a look at this trinomial here, you'll notice we've got much larger numbers to deal with. There's a lot of factor combinations for 12 and for 45. That would be a lot of choices to have to go through to see what would add up to our little middle term. So one option is, remember, first learning to factor, the first thing we looked for was a GCF. We have got one among all of these numbers. We can factor a 3 out, and that's going to help. So place your 3. This will look like the distributive property. When you pull a 3 out of each term, you have 4x squared plus 23x, and now it's a plus 15. That's going to help a great deal because now it's a 4 and a 15 that you need to break down. And you're going to try to get a 23 right here. So let's go ahead and do that. It also limits the number of combinations you have, because you only have 2 ways to get a 4, 1 times 4 and 2 times 2, and you have only 2 ways to get a 15, 1 times 15 and 3 times 5. Now because I want a 23, I don't want to randomly just try a combination. I've only got 4 to try, but I'm noticing here, if I multiply a 4 and a 5 to get a 20, and then the 1 with a 3, I'll get a 3. I can combine a 20 and a 3 to get a 23. Now I need to make sure the signs work as well, so that's the first try I'm going to make. It's a good start. All right, yeah, this way we've got a 12 and a 5, and I know that won't work. If I go up and down, and it all depends on the order that you write your number, whether up and down will work or if diagonal will work. But the way I wrote them, if I go up and down, that's a 3, and that gets me a 20. I can get a positive 23 if I add, with them both being positive values. So in foiling out, what I have done is discovered what my 2 middle terms are going to be. It should be a 3x and a 20x. So again, they don't go inside the parentheses. These are the numbers that will go inside, and I'm going to place the 1 and the 4 first. Please remember to bring down that 3. He's a part of your answer. Now I have to figure out the 2 binomials. To get the 4, I need a 1 and a 4, and it doesn't matter which one you put first, so I can put the 4x first, and then the 1x, the 1 being optional. Because when I multiply and FOIL, 4 times 1, boom, there's your 4x squared. Okay, I made the 4 an outer. He will get multiplied by the other outer, not by this number here. So I need to see what number will be my other outer. Look at who it's linked to. So go over here. Look at your 4. These are the guys already inside. If you multiply going down, we link the 5 and 4 together to be a 20. So I need a 5 here. I need it to be a positive 20 when I multiply this 4 and 5 together. So I do a plus. The 1 is an inner, so the inners are linked together. So over here, there's the 1 that's already inside. It is linked to the 3 going up and down. So I need to put the 3 here, and I want a positive 3 when I multiply, so that needs to be a plus sign as well. And you can always FOIL it out to double check it. Every line should be equivalent to the line above it. So when I FOIL this out, I should get this trinomial. When I then distribute the 3, I should get the original trinomial. Please don't forget the 3 in your final answer. And there is your factored answer. So we'll definitely go over more of these in class.